dealing with symmetry and coordinate graphs. All right. First thing that I would like you to do is I'd like you to draw an x-axis and a y-axis. Draw a coordinate grid on your paper. All right. Label this x, that y. Specifically, right now, we're going to be talking about what's known as point symmetry. All right. So we're going to focus on point symmetry, and we're going to plot some points. Okay. Yes. Sure. All right. So Tyler, give me just a point that can easily be plotted right here. 1, 2. 1, 2. I'm going to go 1, comma, 2. I'm going to call that point A. So we're going to go over 1, up 2. I'm going to put point A right there. I'm going to label it. Okay. Now, what we're going to be doing today is talking about points that are symmetrical about the origin. So I'm going to put a point right here. I'm going to label this point. That's the origin. Now, if we are going about the origin, or symmetrical about the origin, our point, if I had a point called A, comma, B, that would have to become negative A, comma, negative B. In this particular case, Tyler gave us 1, comma, 2. So Ryan, if Tyler gave us 1, comma, 2, and we have to follow this rule right here, what would my image point be? Negative 1, negative 2. That's what's called the image point for this particular problem. Okay? So right here, I'm going to go negative 1, negative 2. And I'm going to put a point right there. I'm going to label it A prime. Okay, so this is A. The image point would be A prime. Now I'm going to make a little dotted line between these. Okay? And something that you should notice that the origin looks like it's exactly where? Exactly in the middle. Exactly in the middle. In order for things to have what's called point symmetry, okay? If you're symmetrical about a point or across a point, that point has to be the midpoint between the original point and what's known as the image point, okay? So that's how it works, all right? So that's just an example, and what we're going to do is we're going to do problem number 1. We're going to do problem number 1 in your journal, and then you can easily transfer the answer over to your paper. So what I'd like you to do is I would like you to make a graph, all right? I believe f of x equals negative 12 divided by x. We're going to make another x and y axis. I'm going to go and do that in positive. All right, so I've drawn a graph, and the scale of the graph, every single little tick mark is going up by 2, all right? So I'm going to make a little table over here with my x values. Something that you should recognize about my x values is I'm only using numbers that are factors of 12. Okay? So I'm only going to be using factors that are 12. So when I'm plugging in my x values, okay? So right here, if I said, what is negative 12 divided by negative 6, that would be a positive 2. What's negative 12 divided by negative 4? Positive 3. Okay, so I want you guys to kind of fill this table out with me. So we're going to have a positive 4, positive 6, and all of a sudden, we'll notice some of our answers are going to be negative. Okay, what I did is these numbers right here, the domain, I'm plugging it in. So at least what I did is negative 12 divided by negative 6 is positive 2. You see the pattern? Okay, yes, right? Okay, because 5 doesn't go perfectly into 12, and I didn't want to deal with decimals. So I was just using points that I felt were easily plottable. Does that make a little more sense? Okay. Good question. All right. So what I want you guys to do, all right, I'm going to go and pause this. I'm going to give you guys a chance to plot some points. I'll let you guys plot them, and then we'll move on. So we have negative 6, positive 2. I'll make them in green. -4, +2. That's going to have to be like between the 2 and the 4. -3, +4, right here. -2, +6. Now, do these points look linear or non-linear? Which means, do they look like they form a line or form like a curve?
Non-linear.
Yeah, like a curve, right? So if we were to actually, we're going to wait to graph them here in a second. We're going to use the graphing calculator and take a look at it, okay? But if I plot the other points, you'll notice it looks the same, except it's on the other side. It's going to be in this quadrant. So we have 2, -6. We have 3, -4, 4, -3, and 6, -2. All right? So let's look at the graphing calculator. All right? And what I'd like you to do is on your calculator, some of you have color, some of you don't, but it's the same steps. Hit y equals on your calculator. You need a calculator? All right. Ooh, there's still colored ones available. Still colored. I'm going to pause it real quick while you guys are. All right, so everybody right now, after you hit y equals, what I want you to do is hit alpha y equals. You see where it brings you to? That in numerator divided by the denominator. Press enter. And in the numerator, I'd like you to type in -12.
Alpha what?
Alpha y equals. Now hit the down arrow right here, hit the down arrow, and then right here where you have the X button, hit the X. Okay? Then hit right, and now you've typed in correctly the equation for our function. Alright? Now what I want you to do right now is hit the graph button. Let's take a look at it. Now, your screen might look different than my screen, correct? Alright, so I'm going to hit right here, everybody at the same time hit zoom and 6. Then everybody will have the same standard screen. Zoom 6 brings you to a standard screen. Alright? Now, what we're going to do, alright, is we're actually going to create the screen that's on your paper. Alright? Now, Tyler, looks like we have, how big is on our paper in the assignment? What's the dimensions, do you think? Looks like about 5, going over and up.
Yeah.
Okay, so here's what I want you guys to do, all right? On your window, I want you to make the x minimum -5. So what I did is I hit the window button, okay? And the x maximum +5. Now, on the graph that we were doing, what was our scale? What were we dealing with our scale? 1 or by 2s? 2. So I want you to make that x scale a 2. We're teaching you how to use the screen, like the window screen. Y minimum, make it a -5. Y maximum, make it a +5. And once again, we want our Y scale, our tick marks, to be going up by 2s. This will give you exactly what I want you to put on your assignment. So when I hit graph, now you can see what it would look like on your assignment. Okay? So right here, here's what the graph's going to kind of look like on your paper when you're done. So you basically made a graph based on your information. Okay? Now, what I'm going to do is I'm going to go over to our graph. Now you can kind of see how you're supposed to connect it. So on your paper, which means in your journal right now, connect the dots. Brian likes going to IHOP because you can go to connect the dots. If the kids' meal, connect the dots. All right, and there is your graph for number 1. Okay, we're going to pause. So we're going to go back. We're going to go back right now. We're changing our window back to -10, +10 because since we're counting by 2s, okay, it should make our graph look a heck of a lot. See? Yes, scale still 2. All right, so now would you guys agree that this graph looks more like our hand-drawn graph? Okay, so I want you guys to get comfortable of using the window settings to zoom into a graph or zoom out based on, what your graph looks like. Okay, now we're going to do a test. Okay, we're going to do a test. in order for this to be symmetrical about the origin, all right, if I take any ordered pair, we'll call it A comma B, what does that have to become in order for it to be symmetrical about the origin? Negative A, negative B is correct. So we're going to take any ordered pair. Let's take negative 6 comma 2. Negative 6 comma 2 should become positive 6 and a negative 2. If we use this guy, use this as our guide. So does that work? Yes, there it is right there. So negative 6 comma 2 becomes 6 negative 2. Now if you find a point and it works, I want you to do at least one more point. Okay? So, Shayla, give me one other ordered pair that you want me to check. That's, yeah, up here. Okay, let's do negative 3 comma 4. And if it follows the rule, negative 3 comma 4 should become what, Liz? What should it become? Negative 3 comma 4 should become positive 3 negative 4. Do we have a positive 3 negative 4? Yes, we do. This right here, everybody, this is what I want on your paper as proof that, yes, we have proof that this is symmetrical across the origin. So this does have what's called point symmetry. So when I say the word yes, I mean yes, it has point symmetry across the origin. All right? And if you look at your paper, it asks you, it says, determine whether the graph of each function is symmetric with respect to the origin. Sketch a graph, we did that. Make a table to prove your answer, and did we prove our answer? Yes. That's what you're going to be doing on problems 2, 3, and 4. So what do I want on every single problem? I want a sketch of the graph. How do I want you to sketch the graph first or make a table first? Make a table, plot the points, use your graphing calculator, sketch the graph, and then at the end, do a proof. If this works, if this point becomes a point that matches it, if AB becomes negative A, negative B, then it's yes. If it doesn't, then the answer is no. That's what I want you guys to do at this point. For problem number 1, yes. Problem number 1, make those by 2s. Make it, basically just take the information and put this right here on your paper. And once again, Ryan, I know you didn't ask this question, I just threw your name out there. This is the proof that yes, it is indeed symmetrical. Okay? All right, we're going to quickly go through one more problem. Okay? This is f of x equals x to the power of 5 minus 2. Tori, I want you to give me the corresponding y values to these x values. Negative 2, what does that become? Okay, negative 34. Negative 1? Negative 3. 0? And 1. Negative what? Negative 1 and 2 goes all the way up to a 30. Okay? Now we can't plot all of these, okay? But I want you to definitely plot these 3 right here. So we're going to go negative 1, negative 3, and put a point. Oh, sorry. Negative 1, negative 3. 0, negative 2. 1, negative 1. Now, if I only plotted 3 points, just those 3, that kind of looks like a line, doesn't it? All right? So that's where these points that you can't plot, it kind of still gives you some perspective. If I say negative 2, negative 34, negative 2, negative 34 would just keep going way, 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 way down. So one thing you'll notice is that as I come up through these points, once we look at the graph, you'll notice it is not a straight line. It goes through these points. But if I'm going to go to 230, would you guys agree 230 is way, it's not even going to cross past it. It's going to go way up high before it actually hits 230. Okay? So if I were to go to my graph, right here, that's what your graph is going to look like. All right? Now, we've plotted points, we've graphed it, now we have to check to see whether or not this is symmetrical in respect to the origin. All right? So here's the last thing that I'm going to do. Does A, B become negative A, negative B? So I'm going to use right now negative 1, negative 3. What should that become? 1, 3. 1, 3. Does it?